travels about 8 months of the year working in international schools. And she first came into the international teaching scene basically through the Office of Overseas Schools. Because of her credentials and her experience in the United States in the area of math and science, she basically has a laundry list of accolades and recognition from her time teaching and working in the United States. She's an Albert Einstein Distinguished Fellow. She was a senior program officer with the National Research Council and assisted in developing the National Science Education Standards. She's a Krista McAuliffe Fellow with the National Foundation for the Improvement of Education, and her engagement and involvement in a lot of the curricular work that has happened in the United States around the areas of math and science is over a long period of time with a lot of really deep interactions in the United States with people who are really responsible for bringing out a lot of the new documents that we're looking at and we're focusing on in this year. And as I said, this is her 4th year with us. She's been really instrumental in supporting our school and our teachers in the areas of math and science to really understand the shifting nature of math instruction and science instruction so that we can basically teach and prepare our students in a way that's going to best equip them to deal with a more complex and globalized world, where we're moving towards a world where it's what you know, but it's also what you can do with what you know. It's the critical thinking pieces, it's the real application pieces, and the recognition of these really important aspects of learning in education, not just in math and science, but also English and social studies as well, are really reflected in some of the national documents that are coming out of the United States from the Common Core. And Irma's going to talk a little bit about the Common Core, I think, tonight. These are both documents that we at AES, through the past year, and our curricular work, our math departments and our English departments took a very serious look at these documents to evaluate them, to see how they could impact our work, should they impact our work, and the conclusions that our teachers came to was that these documents, the Common Core in Math, is a phenomenal guide to help our work with students and to make sure that we are meeting the rigor that's expected when they leave our school and they go to other schools. The beauty of finally having sort of a national document for U.S. education is, as everyone moves towards looking at something like the Common Core, it's going to create a more even playing field for all students, no matter where you are. It will make it a lot easier for students to go between states. Most international schools that we work with in our region have also moved to the Common Core. It's going to make it easier for your children to go from one international school to another international school, because for the first time we're all kind of going from the same directions. That 6th grade at AES will look like 6th grade in Shanghai. And it's going to really, I think, help our students who are so mobile and go back and forth between their home countries. Australia and New Zealand have also done the international benchmarking. Their documents are also very in line with the Common Core. And so this is all going to help us in this international world where kids really can be anywhere at any given time. And on a personal note, as someone who's been working in the curriculum office for 4 years, I really do feel like the past year or two, like we've really seen the fruition and the power of the work that our math and science teachers have been doing. And I think our math and science teachers really need to be commended for all of the hard work that they have been doing to understand these documents, look at their programs in new and inventive ways, and they're so engaged in what's the best thing for us to do for our students to meet their needs in math education. And we do have a few math teachers here tonight, but they really need to be commended for all the hard work that's been going on in the middle school and the high school, and that's really been supported by Irma. So I'd really like to thank Irma and welcome Irma so that she can speak with you a little bit tonight about
It's great to be here. When I listened to Stacy talk about it, I realized how old I really am. You know, I've started my 40th year in this business of working. Probably the most productive time of my life was the time that I taught. I was a classroom teacher. That's my claim to fame. I taught math and physics at high school in a very small school in rural Pennsylvania. And it was from there that I just somehow, I don't know what happened, but I've been on the road for the last 15 years. And prior to going to work with the State Department, I worked with a project called Schools Around the World. And we worked with 10 countries and looking at student And one of the things that we discovered was that we are all teaching the same content in math. But what is very different, and what must be very different, is the approach to teaching mathematics. And that's what I want to talk to you about tonight, is what is happening in math education internationally. And if you go on the web and you go to the OECD, the Office of Economic Cooperation and Development website of whatever country you come from, your home country, you can read about how math is changing in your country, because it literally is changing the way we instruct math. It has to change because we are not preparing students for the 21st century. I look around the room, you're probably all professional. You are probably part of that very narrow 10% who was able to learn math very easily, and so you succeeded. What you have to understand is that in our universities, we have a number of students who have graduated from our schools and cannot do the math that will lead them to the career that they have chosen. And most careers in the 21st century are going to require math beyond high school. So, the pipeline is pretty thin. How do we prepare our students for that future? That's what I want to talk to you about tonight and share with you some things. So, I want to try to answer these questions because these are the questions that I hear. Why do we need to change the way we teach math? Wasn't it good enough when I went to school and somebody taught me a rule and I memorized it and I could repeat it and I could do 100 problems, get the right answer? Why do I now need to change the teaching of math? We teach not for knowing rules, we teach for understanding. So we're going to talk about that and show you what that is. How is it, you all, I look around and you're all so much younger than I am, but I would venture to say that mathematics has changed quite a bit since most of you were in the K-12 system. If not, there is a problem. If not, there is a problem. So what are the current trends in mathematics education? What does it mean to think mathematically? What is mathematics? What is mathematics? And above all, I want to talk about how you as parents should be supporting your children in learning and understanding the mathematics that is going to be essential for the 21st century. So, we're at a crossroads. This is a very challenging world. The jobs of the 21st century are going to require a lot more math than many of our children, understanding of math than our children currently have. So how do we address that? Out of the OECD website, 75% of all jobs will be in STEM. STEM stands for science, technology, engineering, and mathematics. But not just STEM jobs, but there's STEM in almost every job of the future. Technology, global knowledge economy, requires different skills. Business and industry want employees with these skills. Last week, 2 weeks ago, I was in Manila, and we had 175 parents in the audience. At the end of what we had done, we actually did a hands-on math, which we might try with you all tonight. Test your math understanding. And a lady in the back wanted to make a comment. She is the CEO of a global company, and her comment was this. She said, I hire students right out of college. She said, I would give anything if the students I hire could problem solve. What do I mean by that? She said, if I give them a set of directions, they're very good. They can follow those directions, but whatever you do, don't expect them to deviate from the directions that I gave them. She said, I cannot find good problem solvers. The 21st century skills requires critical thinking, good problem solvers. So, as we look at this, what do our employers want? According to OECD, they want people who have higher order thinking skills, are able to collaborate. I have the slide up here in a minute, 4 C's, and that they can solve problems, and you don't need a set of rules to follow problems. What we've got to move from teaching all this arithmetic to teaching mathematics. Think about that for a minute. What is arithmetic? Arithmetic is what many people learn in school. How do you add numbers? How do you subtract numbers? You're going to get a test, by the way. You know that, did you? How do you multiply? How do you divide numbers? If all you have is a set of rules, how do you deviate from that? Do you have good number sense? Are you fluent in mathematics? Those are the questions I want you to answer tonight, because our employers want people who have those skills. The top 10 in-demand jobs in 2010, this is kind of an outdated slide, did not exist in 2004. Think about that for a minute. I don't have to tell you about the amount of technical information that is doubling every 2 to 4 years. Think of the society we live in. What APEC, the Asia Pacific Economic Commission, says, and I love this saying because it says, as teachers, we're responsible for preparing students to address problems we have no clue of what they're going to be. But that knowledge has not yet been developed, and technology that has not yet been invented. When I started out about 12 years ago, working and traveling around, I remember my laptop was so heavy I could hardly carry it. I didn't know how to use it. My son called me technology illiterate because he's a programmer. And today I have a whole suitcase, a little suitcase that's yay big, that has all of my technology tools in it that I absolutely must have for my travels. And that technology is rapidly changing. Learning new technologies every day. This is what we as educators are facing. How do we prepare our students for that future when we don't know what they're going to face, not even 2 or 3 years from now? So, the thing is, I want you to look at this. This is a test of yours. No paper, no pencil. How would you solve this problem? By the way, just to kind of reduce the anxiety, it's a 4th grade problem. How would you solve this problem? Think about it. Okay? I'm not going to ask anybody to answer it, but we're going to talk about that for a minute. What is mathematics about? Mathematics is really a way of thinking. But how do most children view mathematics? That is a set of procedures, a set of rules. Let me tell you how 4th grader would solve this. There's 36 bicycles and tricycles. A bicycle has 2 wheels, a tricycle has 3, so everything has at least 2 wheels, so I've used 72 wheels, so there's 8 wheels remaining, so therefore there must be 8 tricycles and the rest must be bicycles. But now we could solve that with algebra. We could write a system of equations, and remember how we did that? Bicycles plus tricycles equals 36. 2 wheels on a bicycle plus 3 wheels on a tricycle equals 80. Solve those 2 simultaneous equations. I will be compliant to what you want, but I have no clue what I did. Whereas if I teach my children to think mathematically, I can solve most problems. Asia Pacific Economic Commission, we're going to talk a little bit about the Common Core, but back a few years ago, they did, and you can look at their website, the education part of it, and they did a survey of the mathematics that was taught around the world, particularly in countries that border the Pacific Ocean, their countries, APEC countries that scored high on TIMSS, Third International Math Science Study, and countries that scored high on PISA, performance and student achievement, given to 15-year-olds in 80 industrialized countries. What they learned was that the mathematics content we teach in all of these countries is similar. The content of mathematics does not change. What was different was they said high-performing schools give their children a map. Low-performing schools give their children directions. Think about that. I give you a set of directions. You go out here. I have no idea where I'm at, so I can't give you directions. But if I give you a set of directions and you go out here, what happens if you make a wrong turn? You either have to stop, you have to ask directions, you have to turn around, retract your steps. But if I give you a map, what can you do? I can find an alternative route. Giving our children a set of directions is teaching them arithmetic. Giving our children a map is teaching them to think mathematically. We want our children to be able to think. Critical thinking skills are important. Now, a good balanced mathematics program has the conceptual, that understanding, the procedural, those rules, that arithmetic, but it is really highlighted by the kinds of problems we ask our children to solve. So, when I solve this 4th grade problem, how do I think about it? Do I have to think arithmetic, or do I have to think, oh, I got to write 2 systems of equations, or do I approach it and try to think through it? Getting our children to think. So what is mathematics? It's a way of thinking, understanding, and expressing phenomena. So it is more than computation. It is more than memorizing my fact families, which I soon forget. It's about thinking. We want our children to be good thinkers. So, if I move on here, do we teach our children to do mathematics, or do we teach them to understand mathematics? There's a huge difference between teaching children to do mathematics, that's teaching them a rule, and understanding mathematics. We're going to assess you here just in a second, so just be patient with me. I'm getting there. So anyway, we want our children to be able to teach them understanding. It doesn't do any good to teach them a meaningless rule that only works for a 3x3 determinant. If I can't take that and I can't apply it in any other way, how do we generalize what we're doing? How do we get that understanding? So, our literature says, in all of the research, all children will become fluent in mathematics by the time they leave school. Are you fluent in mathematics? Don't answer. Think about it. Are you fluent in mathematics? What does it mean to be fluent in mathematics? Here's the test. You ready? No paper, no pencil. If you are fluent in mathematics, you could answer those questions within a minute. Are you fluent in mathematics? A majority of adults are not fluent in mathematics. Why? Why? Did you all want to reach for the paper and pencil? Did you all look at that division problem with fractions? Did you all want to invert and multiply? And oh my gosh. That division problem, did you think about how am I going to set it down? Put that little thing up there? This is why children get frustrated with mathematics. The literature is very clear. By the time they reach 5th, 6th grade, they have already been turned off of mathematics. They are frustrated. They feel like they can't do mathematics. So if we teach them to do mathematics, absolutely, a lot of children cannot, quote, do mathematics because I can't remember all the rules. But if you help me to learn and understand mathematics, then I'm able to take that information and I'm able to apply it in at different situations. So, fluency, I don't have time to answer all those questions, I forgot. So, if I ask you if you were fluent in reading, I would ask you, what does it mean to be fluent in reading? It means that you can read with comprehension, you understand what you read, you don't have to over words. It means you read with accuracy, and you can read with efficiency. So, you would never hear anybody say, I can't learn to read, would you? Or I can't learn to do history. Don't raise your hands. But how many parents say to their children, don't worry about it, I couldn't do mathematics either. I didn't do good in mathematics. The literature says that is a no-no. Every parent should tell their children, even if it's a big lie, how well you were in mathematics and how much you enjoyed mathematics. Why? Because the foundation is laid by 4th grade for mathematics. The National Research Council added it up. It says by grade 4, all the mathematics you need to know has been taught. 5 to 8, we give breadth and depth. That's the purpose of the middle school, to give breadth and depth to what was learned in the elementary. At high school, children enter the various pathways. Now here's a scary thought. When children struggle with mathematics by the end of grade 4, the literature says, unless there is intervention, they will be in remedial mathematics through college. Why? The foundation is weak. So what we're talking about here is in the middle school, we would expect children to come to us being fluent in mathematics. What does it mean to be fluent in mathematics? It means that I am efficient, I am accurate, but here's why most adults are not fluent. It means I am flexible with numbers. Flexibility with numbers. If all I know is a rule, that problem I gave you about the bicycle, you're thinking about what procedure am I going to use? But if I've been taught to think, I think about it as a problem that I need to solve, and it doesn't require the writing of equations. 28 plus 32. I'm doing real simple. We'll do a second grade one, okay? 28 plus 32. If I ask you to find that sum, I have so many ways of doing it. I don't have to set it down and keep my one straight and then carry whatever that is in math and get my answer. I know that 50 and 10 more makes 60. 28 and 2 more makes 30, and 30 more makes 60. I have flexibility with numbers. So if I'm fluent with mathematics, I'm efficient, and there's the definition of efficient. I don't get bogged down with too many steps. I am accurate. I know my facts. I know my combinations. And above all, I have more than one approach to solving the problem. I am fluent. How fluent are we in mathematics? So, it also says we will all lead with good number sense. What is good number sense? There's the definition. You have a good intuition about numbers. How do you get that? It's developed over time, and this is what you see in our schools. This is how mathematics should have changed and must change, is that children get an opportunity, and I'm talking about children, I'm talking about from all the way from the pre-K up through high school, to explore mathematics, to look at that next word, visualize mathematics. And it says in a variety of contexts, not limited by traditional algorithms. So if I say to you, 1 divided by 2/3, what does that say to you? We're doing semblance here, okay? We're back in elementary. We're going to move up to middle school here in a minute. What does it say to you? What does it mean to you? What do you see when I say 1 divided by 2/3? Is all you, and I don't want anybody to make any comment, do all you see are numbers? Do all you think of, what comes to mind is, oh, I got to invert and multiply. Oh, numerator times numerator. what do you see? Do you understand what division is? This is what we want our children to know. 1 divided by 2/3, what does it say? It simply says, how many 2/3 are there in a whole? How many are there? Well, how many 2/3 are there? How many 1/3 are there in a whole? We didn't bring the blocks, did we?
The right page.
Oh, okay. Let's just do this real quickly. We're only in 3rd grade. We're going to move to high school here soon. Because it says simply, how many thirds are there in a whole? Well, you've got the picture there, right? How many thirds are there in a whole? 3. Good. How many fourths are there in a whole? 4. So 1 divided by 1/4, there are 4. Now I ask you, I said, how many 2/3 are there in a whole? You got the visual? You got a picture. Because remember that to understand mathematically, conceptually, I have some sort of an image, some sort of a visualization. Because look what number sense was. By exploring numbers, visualizing them. So, here's my whole. My question was, how many 2/3 are there in this whole? Isn't that what I asked? How many of this are in this? That's division. That's what they learn in pre-K. And then in 3rd grade, they begin, 4th grade, they become fluent with dividing fractions using a model. How many are there? There's one group, you see it? And I have this little fellow left here, 1 out of the 2, 1.5. You got a picture? You got a picture. This is what is really critical for young children because middle school fractions, ratios, and proportions are critical. A child who comes to middle school not understanding what it means to divide fractions is going to be lost. He's going to try to remember the rules without understanding why he inverted and multiplied. So, get a picture. 1 divided by 5/6. What does that say to you? How many, you can talk to me, 5/6 are there in a whole? Well, that means my whole has to have 6 parts, right? There it is. A whole. How many, we say together, 2, it's right.
I might not have given them enough blocks.
Okay.
They may have to visualize it.
Right, I will have to get visualization. So how many of these are in this? I have one group, right? But I have that one left over, 1 out of, how many did I need? 1 1/5. And if we did this enough, we got that picture, that visualization, then we can talk about why do we invert and multiply? Does that make sense? I want you to understand the math, because in the literature, adding it up, how children learn mathematics, I'm going to share with you some resources here. It talks about if children do not have this understanding, it does not do any good to teach them a rule that they're going to forget. This is how mathematics has changed from the time that I went to school, which was many, many years ago. I have to share my story. How many of you were here last time? Okay, well, you have to listen to my story again. I graduated from college. I was good. Man, I was going to set the world on fire because I had a math and a physics degree, and I'm going to teach in this school, and by darn, I want to tell you, these are going to be the best students ever. My first week at school, I had 12 young men in a math and a calculus class, and I had the same 12 young men in a physics class. I remember vividly, I was teaching my heart out. I was teaching my heart out. And they could not do anything that I showed them. My 3rd day, I went home and I said to my husband, and you've got to forgive me, these are the dumbest kids I've ever met. There is no way I'm going to teach them. I show them something and they can't do it. I show them again and they still